Hello everyone, my name is Greg and today I would like to walk you through 5 questions from the latest flight planning exam seen in the last 30 days across all authorities. Topic for today, IFR flight. Question number 1. A pilot is planning to follow an IFR route between 2 airports. One of the segments is across longer distance of water where the route segment has been given the 2 limiting altitudes specified below. How can the pilot correctly apply these limiting altitudes? MEA 4,500 feet and MOCA 1,500 feet. So the correct answers are: use the MOCA value as the minimum safe altitude within the dimensions of the route, and MEA if flying within 25 nautical miles of the route central line. Plan to fly at 5,000 feet or above to clear obstacles and to have adequate reception of radio navigation aids and communications. Plan to fly between 2,000 feet and 4,000 feet in order to remain within protected and authorized dimensions of the route segment. Use the MEA value as the minimum altitude to achieve the required obstacle clearance for IFR flight, as the MOCA value is for VFR flight. Okay, let's start with defining what MEA and MOCA actually are. First, let's talk about MOCA, the minimum obstacle clearance altitude. It is an altitude that provides a minimum obstacle clearance for a defined segment of a flight. For example, for the en route phase of an IFR flight, it is 1,000 feet with an increase in mountainous terrain to 1,500 feet if variation in terrain elevation is between 3,000 and 5,000 feet, or up to 2,000 feet clearance if variation is above 5,000 feet. MEA, on the other hand, is the minimum en route altitude that provides adequate reception of relevant navigation facilities and ATS communications, and provides the required obstacle clearance. So as you can see, MOCA is already included in MEA. Therefore, in our case, we would plan to fly at 5,000 feet or above to clear obstacles and to have adequate reception of radio navigation aids and communications. Answer number 2 is correct. Let's move to question number 2. The sector time from waypoint Charlie to destination in line 4 of the navigation plan is 11 minutes or 8 minutes, and the accumulated time to the alternate in line 5 is 56 minutes, 1 hour 25 minutes, 46 minutes, or 1 hour and 15 minutes. Okay, if we check the given nav log, we can see that the distance from waypoint Charlie to the destination is 15 nautical miles, and our speed at this leg is 80 knots. So first, we are calculating our speed factor. So how many miles we cover in 1 minute? 80 knots divided by 60 and gives us roughly 1.33 nautical mile per minute. Now, to find our time, all we need to do is to divide our distance by speed factor. So 15 nautical miles divided by 1.33 gives us roughly 11 minutes. Let's find now our accumulated time to the alternate. Just a short reminder that accumulated time is a total time from our departure or from the first navigation waypoint, whatever is applicable. So, in this nav log, the last accumulated time input we have at waypoint Bravo, and it is 29 minutes. We can see here that the leg from Bravo to Charlie will take 25 minutes, and we just calculated time from Charlie to our destination. Only thing missing is time from the destination to the alternate, which is quite straightforward since our speed is 60 knots in this leg. So we'll cover 20 nautical miles in 20 minutes. Okay, let's bring all this together. So 29 minutes plus 25 minutes from Bravo to Charlie, plus 11 minutes from Charlie to the destination, plus 20 minutes to the alternate gives us 85 minutes. So the correct answer is answer number 2. The time from waypoint Charlie to destination is 11 minutes. And the accumulated time to the alternate is 1 hour and 25 minutes. And answer number 2 is correct. Question number 3. An aircraft being operated for a commercial air transport flight has an approach climb gradient capability of 3.7%. 3 instrument approach procedures are available and listed below. Which of these could be selected for that flight? ISDME approach with a minimum gradient required at 3%, LOG-DME approach with a minimum approach climb gradient 3.7%, or VOR-DME approach, minimum approach climb gradient required 4.2%. Okay, so the purpose of the minimum approach climb gradient is to ensure a safe misapproach with one engine in operative and in an approach configuration, so flap set for approach and gear up. So we as a commanders, as a pilot in command, we always have to check if our aircraft's approach climb gradient capability is equal or greater than the one required by the procedure. Keeping this in mind and coming back to the question, we can see that this aircraft has 3.7% approach climb gradient. So from the given procedures, we can only perform the ILS DME or localizer DME approach that have 3% and 3.7% misapproach gradient respectively. The VOR DME here has a required 4.2% gradient, which is higher than our aircraft's performance capability of 3.7%. Therefore, we cannot use this one. So the correct answer is answer number 1, ILS DME and LOC DME. These are the procedures that we can select for this flight. And answer number 1 is correct. Question number 4. Who is responsible for terrain separation during an IFR flight at night on an ATS route? The aircraft owner, the pilot in command, the operator, or the air traffic control service? Now, there's a lot of this kind of questions in the database, especially in air law. And what you have to remember is that the pilot in command is always responsible for terrain separation. Doesn't matter if it's IFR flight, VFR flight, day or night. There's only one exemption from this rule, and it is when we are under radar vectors. Then it is an ATC responsibility to provide terrain separation. However, please remember that at the same time, it doesn't mean that the pilot in command is not obliged to consult minimum vectoric altitude chart to ensure that adequate separation is provided. So the correct answer is answer number 2. Pilot in command is responsible for terrain separation. And this answer is correct. And the last 5th question. What is the magnetic track and distance from GOLES to Pole Hill VOR? And we have to refer to the Jeppesen chart ELO tool. Let's open it. Okay. First, what we need to do is to find the appropriate points. It might be a bit tricky since not every meridian is marked with a degree. Here we have a prime meridian of 0, 0, 0 degrees. So here is the 001 west, and here barely visible meridian 002 degrees west. Here, for example, we can identify the 5-3 north and 5-4 north parallels. Now, let's find GOLES going point, which is here, and all here view arm to west of GOLES. Just next to GOLES, we have a magnetic track that we have to follow, which is 284 degrees. And the distance is the sum of 10 nautical miles to Batley and 27 nautical miles from Batley to Pole Hill. So the correct answer is answer number 2, magnetic track of 284 degrees and 37 nautical miles of distance from GOLES to Pole Hill VOR. And the answer number 2 is correct. All right. Thank you very much for today. I hope you enjoyed and see you next time.